Hello, I am Dave Ackman of the Gateway Division of the National Model Railroad Association, and I'd like to welcome you to this seminar on creating fire effects for model railroads. In this clinic, we are going to cover fires of differing sizes, from campfires and fusees to dumpster and structure fires and forest fires, and in different dimensions from visual effects to audio and even smells. We're going to review commercial products and cover how to build our own and even a bit about weathering your own structures to make them appear charred. By the time we are done, I hope you get a warm feeling for creating fire effects for your model railroad. Let's start by looking at a commercial product from Woodland Scenics, Betty's Burning Building, which, in HO scale, retails for $83.99. It is designed to run on their Just Plug lighting system, which, with a power supply, will set you back about another $47. Still, it has flickering colored LEDs simulating an active flame, is well detailed and charred, and catches one's eye on the layout. But what makes this product a good starting example? We might consider the multiple colors of the LEDs resembling a fire, how they flicker independently, and the charred appearance of the structure walls. We would do well to consider these factors and perhaps others in any commercial or self-designed fire effects. I bet that most model railroaders considering fire effects think first about hobo campfires. At least for me, this is where I started decades ago. I bought one from Cirkit, and the last time I checked Walther's website, it is still available for about $41. It didn't come with a pile of logs, so I made my own. Back then, it had a single grain of rice-sized bulb on a circuit that made it flicker. I powered it with a 12-volt DC wall wart. It has been quite dependable, but I think I'd go with LEDs or light-emitting diode technology going forward. Okay, we do have to get a bit technical regarding LEDs for a few minutes. LEDs come in many sizes, but the ones I use most frequently are 1.8, 3.0, or 5.0 millimeters in diameter, with a small lip on one end and a curved dome on the other. Some flicker by themselves and others don't. 2 wires are all you will find on most LEDs, and the longer one goes to the positive side of the power supply, the anode, and I bet you can figure out where the shorter wire goes. Individual LEDs typically consume 20 milliamps of power and require between 2.2 and 3 volts of direct current. Some others even run at 5 volts. But if you put too much energy through an LED, it will blow. Good thing that these things are relatively inexpensive. That's all well and good. But what if you want to use a power supply above the rated voltage of the LED? No problem. You just need to put a resistor in line with the LED to lower the voltage across the device. I'll spare you any more math, but the table here shows the minimum size resistor you will need for various voltages and various sized LEDs. If you use a larger resistor, well, the LED won't be quite as bright or might flash slower. If you use too large of a resistor or have the LED wires reversed, the LED won't fire at all. Where do we get resistors? Amazon, of course. I typically buy a 100-pack of 1/4 watt resistors for less than a Big Mac, or even less for smaller quantities. Typically some 100 ohm, some 220 ohm, and some 500 ohm resistors are needed to cover all my bases. Or perhaps an assortment of resistors is more your style. One other thing, some commercially packaged LEDs come with an internal resistor and can run at voltages up to 18 volts without burning up. Just keep your wits about you and pay attention to the limits of your LEDs and the output of your power supply. Oh, if you accidentally reverse the LED wires, it probably won't harm the LED, so just flip them over and try again. And if you are colorblind, as I am, when you buy resistors, place them in an envelope and label the envelope with the resistance, so you won't need to fumble with reading the color codes. The absolute least expensive approach to a campfire is a flickering tea candle from the dollar store, 2 of them for $1. They are battery powered and come with a switch of sorts and are usually 5 millimeters in diameter, a bit large for an HO scale campfire, but certainly suitable for larger scales. Actually, the switch is not an electrical switch, but is a lever pushing a lead of the LED onto the battery. The neat thing about these units is that they can be disassembled down to the LED in the battery, so they are easier to install on a layout than when they come in their cases. Of course, you can power them with any other 3-volt source, including a pair of AA batteries, a CR2032 3-volt battery, which comes with the tea candle, an Arduino, or a wall wart. There is also a switch and battery combination, which is really convenient. And if you don't like the color, just dunk them in a jar of Tamiya transparent orange paint. Too much work? Another option for single flickering LEDs is from a website called evandesigns.com, and you really need to know about these folks. Evan Designs recently became an NMRA partner and offers NMRA members an 18% discount with the NMRA MEM discount code. But for me, the real benefit is their extensive product offerings. 8 different colors, multiple sizes, and 3 different voltage options. You can get into the game for $3.85. Their LEDs have longer leads, too. I use individual orange, yellow, and red 3mm LEDs for many of my fire effects. Occasionally, I use their clear and blue LEDs for special effects. But what I really like using is Evan Designs' Fire LED Kit. For $6, you can get a 3 LED set with a flashing red, a flashing orange, and a solid orange LED, complete with resistors, running at anywhere between 3 and 19 volts, and you only need to hook up 2 wires. Want even more flicker? Hook up another set or some additional single LEDs. It's really pretty cool. Check out http://evandesigns.com/products/fire-led-kit. This is starting to look like something Woodland Scenics uses in their Betty's Burning building, and you can include 1 or more of these clusters in your own building for $6. Their fire kits come in differing sizes, up to 5 millimeters in diameter. Higher voltages yield brighter lights and faster flash rates, but might reduce the life expectancy of the LEDs. But we are not limited to campfires with this circuit, or with individual flashing LEDs. We can put them in a barrel to create a place to warm our hands, or in a fireplace in a cabin, in a barbecue grill, or in a dumpster fire. Surround the LEDs with whatever suits your needs and imagination. Some of these can even be used in a mobile environment, but I have yet to give these a try. You are on your own when it comes to logs for your campfire. Of course, some small pieces of dowel will look good in a teepee or stacked in layers. You will probably want to paint or stain them for a charred look. A circle of small stones or talus would keep the fire from spreading. If you have a 3D printer, there are some log arrangements on Thingiverse.com which might work for you. On my website, I have a pointer to one of my own designs on Thingiverse, designed for HO, and which uses a 3mm LED, so help yourself. Perhaps you might want to include a bucket full of water nearby, in case the fire starts to get away from you. I was a Boy Scout and can vouch that a fire bucket is a very good idea. There is also a pre-wired LED campfire from Viessmann and a log set kit from Fowler without an LED. I am sure there are others, but making your own is part of the fun. A commercial solution is about as easy as things get, but if you want more flexibility and are into Arduino microprocessors, you can create something with a different number of LEDs and different colors of your own choosing. There is a program on my website, http://dackm.github.io, which you can download into an Arduino to allow you to control up to 9 LEDs, altering their flicker rate, color, and brightness randomly and individually to your specifications. LEDs bought in bulk are inexpensive, about a nickel apiece, and an Arduino Nano and an expansion board can be purchased from Amazon for about $8. A Nano can be powered from a battery pack or a wall wart. The power of my sketch is that it gives infinite control over each individual LED and can be used to give random lighting in a building as well as an exterior file. Here you see my Monty's Motors building with randomly controlled white illumination lighting. Just as easily, I could replace the clear LEDs in each room with individually Arduino-controlled red and orange LEDs, flickering much faster at any rate I desired. Flickering LEDs are a good start, but what if we could add sound? Engineering.com has some inexpensive sound units they call Little Sounds, starting at $19.99. I tried their 084 campfire sound, and while it was okay for a campfire, it was too quiet for the forest fire I wanted to create. Their electronics are simple, but require some delicate soldering and need at least 7 volts to run. They also have a little bigger sound circuit for $36.95, which features a stronger amplifier, larger speaker, and produces a much louder sound. I liked it better, especially with their 096 forest fire sound. The next sound you will hear is from the campfire. And here is the little bigger sound of the forest fire. And finally, a forest fire sound I downloaded from freesoundhub.com. This sound could be placed on a micro SD card and played back using an Arduino-controlled MP3 player. Engineering can also create custom sound modules for a small fee from your own sound file. A speaker enclosure is almost essential to produce a great sound, but none are included in their kits. However, an enclosure can be created easily using 3D printing. A pointer to 3D model files of speaker enclosures I have created is available on my website, http://dackm.github.io. It's up to you whether you buy a pre-made sound circuit or build your own with an Arduino. If you go the Arduino route, by the time you buy an Arduino Nano, breakout board, wall wart, voltage regulator, MP3 player, amplifier, speaker, barrier strips, and a micro SD card, the price is going to be about a wash. But if you like to tinker and are interested in learning about Arduinos, well, this could be a good project to learn about audio. If not, consider the engineering solution. Your choice, but either way you will need some fine soldering skills. Fusees are fires, and if you are into operations, take a look at the Fusee Pro and the Fusee Pro M, M for mobile, from Logic Rail Technologies. Both units can be used to protect stopped trains, and the stationary model can also be used to add flare visibility to other non-rail accidents. The duration of the flare is adjustable from 38 seconds to about 10 minutes based on a potentiometer, and dims down as the flare is exhausted. The Fusee Pro M could not be easier to use. You just drop it on the rails, DCC only, and it bursts into action. When your train is ready to resume motion, just pick it up and be on your way. I tested it on my HO layout, but it might not fit on other scales, so check it out if your scale differs. The stationary unit can be controlled by a single pole, single throw switch, or other piece of electronics and is scale independent. But the LED must be placed in a fixed location on the layout. Just a couple of fun pieces for operations for $14.95 for the mobile model and $28.95 for the stationary model. Getting back to buildings, lights and sound are a good start, but we need to think about what fire can do to our buildings, and by this I mean weathering, charring our buildings. If the fire has advanced to the roof, well, we should have some part of the roof missing, possibly with exposed beams in a charred state. This means some black or gray weathering. Betty's burning building gives us a nice approach. Possibly some windows and walls should be weathered as well. But now it's time to amp up our game. We need a bit of motion, like we can get from a smoke generator. Why? Because the smoke is moving, and it looks great when the light from the LEDs bounces off. Smoke generators from Sutha come in different sizes and voltages, but be careful because they can draw quite a bit of current, possibly more than an Arduino can handle through a single pin. So if the whole scene is controlled by an Arduino, a relay or transistor may be necessary to control that power line. But I am not the first one to use smoke and LEDs for fires. Andy Zimmerman has posted several photos of his in the Achievement Program Scenery section of the NMRA Interchange. And Daryl Ellis did some similar work for the Colorado Model Railroad Museum, so check out their work on the internet. Stan Carlson from Salamanca, New York, also posted a nice fire scene video on Facebook on 30 January 2023 using a smoke generator, and I like how the smoke plays off the flickering LEDs. It's worth your attention. Smoke is heavy relative to air, and Daryl Ellis from the Colorado Model Railroad Museum found that the smoke needed a boost to get it high enough to be seen as desired. So he added an aquarium pump, chimney, and a fan to make the effect more visible. Some screen in the forest floor allowed the smoke to pass through the scenery. But smoke generators aren't the only way to generate motion. Have you ever used a small vaporizer or humidifier to generate water vapor? These things are pretty neat. I bought one from Amazon, and it is the complete enchilada, all for $27. Amazon ASIN B0BV M67K71. It has a bunch of LEDs around a vaporizer, and when you press the button, the orange LEDs kick in, and it looks like a great fire. The unit is pretty big, so plan accordingly, and it won't start unless you press the button, but it just might be worth the hassle. I may try to take one apart and see if I can overcome some of these issues. There is an old saying in manufacturing. Sometimes you have to shoot the engineer and get the product out the door. Well, I have a degree in mechanical engineering and decided I could do something smaller and less expensive than the big commercial vaporizer, and was somewhat successful. There are ultrasonic vibrators, which are vapor generators, so I bought two different models and gave them a try. These things run off a 5-volt USB transformer, but the kicker is they need one that can supply 2 amps of current. The low current converters running at 1 amp won't do. One of the vaporizers, a small disc and circuit board from Amazon, ASIN B0B QWT SV7J, comes with 2 units for $9 and never worked for me. But a single unit from Amazon, ASIN B09J4 8J6JJ at $8.79 did. I just put this unit on top of a small wet sponge, plugged it in, touched the start button, and I had vapor. Just make sure the side of the disc with the soldered wires is on top. The vaporizer disc tends to be delicate and unreliable, but replacement discs are available separately. As delivered, the wires between the circuit board and the vapor generator were a bit short. No matter, I just spliced in a couple of extension wires. But it was a pain to keep pressure on the disc, so it was time for an engineering enhancement. I made something akin to an old-time matchbox with a cutout on the top and just deep enough to keep pressure on the wet sponge, and it worked quite well. I made it so that the tray could slide out from the cover and cut a slot on one end of the tray for the wires. I printed the container on my 3D printer, and a link to the STL file is on my website. If you aren't yet into 3D printing, you need to start thinking about it. But I couldn't stop there. I made a cradle to hold the matchbox and then built wings to hold some LEDs on either side. Yeah, a link to that model is on my website as well. Oh, there is one other thing about using vaporizers. You can add just a few drops of a campfire essential oil and give the scene the scent of burning wood. It's not everybody's thing. It really isn't mine, but it may be yours. Campfires in buildings are great uses of fire effects. But what about brush fires, trestle, and forest fires? It's just a matter of scale and being able to disguise the smoke or vapor generator. You may want to place brush or trees on a hill or come up with an idea of your own. I often visit Thingiverse.com for ideas for 3D printing, and recently found an HO fire escape from Gary Levart, thing number 6115872. I know there are similar items available from Walthers, but I want to print this thing, possibly modifying it to fit my needs. So if you are also into 3D printing, you may want to check it out too. It is now August 8th, 2 weeks before this clinic is scheduled to premiere at the 2023 Texas Express Convention of the National Model Railroad Association, and I discovered a YouTube video from Wicked Makers, Jamie and Jay, where they show how they make their home appear to be burning for Halloween. They use satin drapes behind their windows, made to move with box fans, and lighted with full-size color LED light bulbs, and the illusion looks really good. I don't have time to reduce the idea to HO before the conference, but by now you know all about colored LEDs, and I do know that small fans are available from Amazon, and might be driven directly from Arduinos or other 3-volt power supplies to simulate the effect. I might even try to use colored cellophane instead of cloth for better reflectivity. In a few months, I may have an updated version of this clinic at my website, and I may have this up and running. It's a high priority. Before we wrap up, I would like to thank Engineering.com and LogicRailTech.com for furnishing me with evaluation products for this clinic. Okay, that's all I have on the topic. If you create something of which you are proud, put a video online and send me a link. If you get a new idea, well, my email address is on my website, http://daacm.github.io. I hope you enjoyed the clinic, and as the 60s rock group The Doors used to say, come on baby, light my fire.